Babies. Now we're going to talk about transforming our graphs. So now we're not only going to list the transformations in order, now we're also going to graph them and state the domain and range of these transformed functions. All right, so the very first thing I'm going to do is I'm going to look at this first function, and if you can see that square right there, that means that we are going to have a parabola. Okay, so that's what that means. And the parent function for the parabola, I'm just going to graph it here so we'll have kind of a frame of reference, although I did not do a great job graphing that, but that's totally cool. All right, so let's list what our transformations are going to look like. And I'm going to use another color here so you can identify which one's which. Okay, so right here in our equation, since I've got x plus 5 in parentheses, that means I'm going to be moving to the left 5, and then this negative 3 here means I'm moving down 3. Okay, so what is that going to look like? Well, it just means that this function that I have drawn here in blue is going to move to the left 5 and down 3. So I'm just going to go over left 1, 2, 3, 4, 5, and down 3. The width doesn't change. So from there, all of my ordered pairs are going to be just as they normally would. And if you're confused about how I'm getting these values, remember that you go over to the right 1. 1 squared is 1, so you go up 1. And if you go to the right 2, you're going to go up 4 because 2 squared is 4. So that rule for a parabola doesn't change just because you're moving it around. Okay, awesome. So that is what the new equation would look like, or the new function, the transform function would look like. All right, so we listed these in order and we've graphed. So now we're going to state the new domain and range. So the domain, well, since it goes to the left forever and to the right forever, that means that my domain is going to consist of negative infinity. Oh, I didn't do a very good job with that. Negative infinity to positive infinity. And the range, well, if you'll notice, it starts right there and then goes up. So the range is going to go from negative 3 to positive infinity. The reason I used a bracket right there in the range is because it includes negative 3. All right, so let's look at our next problem. So let's use another color just for funsies. All right, so again, this is a parabola because it's squared right there. So what are our transformations? Well, I've got a transformation of right 2. I've got a reflection about the x-axis. Oh, I did not do a very good job writing that. So we're reflecting over x. This 3 right here tells me that y changes by 3, and this positive 4 tells me that I'm moving up 4. Now, remember, I'm just writing this in order like I taught you, horizontal and then vertical at the last, because of a function like the square root function. For a parabola, the order really doesn't matter how you draw it, just so you know. Okay, so here we go. Let's look at what our original parabola would look like. So we've got, there's our parent function. So now we're going to apply these transformations, and it's going to, the width is going to change this time. All right, so what I'm going to do is anchor that vertex first. So this vertex is going to move to the right 2, and it's going to move up 4. Since we're reflecting over x, that means this parabola is going to open down now. But we have to pay attention to what's happening with this y by 3. So now if I move over 1, instead of moving down 1, I'm going to move 1 times 3, which is 3. So see, this parabola is going to be much skinnier. So when I move over 2, instead of going 4 down, I go 6, because 2 times 3 is 6. Or actually, that's not right. I was not thinking about that. Shame on me. So over 2, and instead of going 4, 4 times 3 would be 12. Sorry, that's what I meant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it's off the graph. Okay, good job, Miss Griggs. Okay, so that's not, oh, it's okay. All right, so domain and range now. My domain is still going to cover all real numbers because the x values, remember, go this way, and since this is extending down forever, eventually all of the values will be covered. And then your range, of course, see where that is? That is at positive 4. So you can write it this way, negative infinity up to positive 4, just like that. Okay, and our very last example, the dreaded square root. Dun, 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 dun. So the square root function. Okay, so here we have a shift of left 2, and order is very important this time, so we have to move it left 2 first. And then y changes by 1/2, and then it moves down 1. Okay, so when we're looking at this, let's first look at the parent function. What would it look like? Well, the parent function for a square root is going to start at 0, and then I'm going to choose values that I can easily take the square root of. So when I've got x is 1, the square root of that is 1. When I've got 4, the square root is 2. Okay, so that's what the parent function looks like. So how is that going to change? So let's look at our transformations. The first thing I'm going to do is move that vertex to the left 2, and then y changes by 1/2, which means that instead of going over 1 and up 1, I'm going to go over 1 and up 1/2, and then over 4, and rather than going up 2, I'm going to go up 1. So that's what would happen there. And then I'm going to move down 1. So I'm going to use my values moving to the right 1 and up 1/2, and over 1, 2, 3, 4, and instead of up 2, I'm going to go up 1. So that is what that would look like. That would be your final answer. Okay, so let's look at, and notice here, if I had moved down 1 and left 2, I would still end up in the same spot. The reason we have to pay attention to order is if we have any kind of reflection. When there's a reflection, it screws everything up. So with a square root function, the order is most important when you have a reflection. That's when things are critical. All right, let's do the domain here. Domain is different for these because the domain here is -2 to positive infinity. And then the range starts right there. So it's going to be from -1 to positive infinity. So there you go. Have fun with it, kids.